So in this video, I'm going to be determining the trigonometry of special angles 30 degree and 60 degree. I have actually showed it in the previous video for angles 45 by 45 degrees. So for 30 degree and 60 degree, we would need an equilateral triangle of length of side 2x units, right? So first thing is for us to draw an equilateral triangle. So the equilateral triangle I'm going to be drawing, okay, so it will be like this. And please note something, that for an equilateral triangle, each of the internal angle is 60 degree. So this is 60, this is 60 degree, and this is also 60 degree. So the length of each side is this is 2x, this is 2x, and this is 2x. So what we do is we need to bisect. We need to produce a perpendicular bisector from the vertex. So if we do a perpendicular bisector, this will be 90 to this side, this will be 90 to this side. So if the length of, okay, let's say this is A, let's say this is B, and let's say this is C, right? So AC is 2x basically. So half of AC, which is half of 2x, will be x. This will be x. So let's call this M. All right, so we can, and of course, since B has been bisected, so it implies that this angle here will be 30 degree, and this angle will also be 30 degree. So what we want to determine now is that we can pick triangle ABM or triangle BCM to actually get what we are looking for. All right, and we are still going to be getting the same answer. So let me just say from triangle ABM, so from triangle AB M. So let me quickly draw that triangle. So triangle ABM will look like this. All right, so let me put it this way. This triangle ABM. So for this triangle here, don't forget that this is this is 60 degree. So this is 60, this is 90, and definitely this will be 30 degrees. So this is A, this is B, this is M. So this is 2x, this is x. So basically we need the length of this side BM. So for us to get the length of the side BM, we need the Pythagorean theorem. And Pythagorean theorem states that the square of the hypotenuse, which is AB in this case, because the side facing the right triangle, is the sum of the opposite length of the other two sides. What do I mean? We can see that AB square is equal to AM square plus BM square. So what is AB? That is 2x square is equal to AM. What is AM? That is x square plus BM. So we have BM, square. But we need BM basically. So 2x square will give us 4 x square is equal to x square plus BM, square. All right. So the next thing we need to do is to, collect like terms. So if we bring x square in, we have 4x square minus x square is equal to B M square. 4x square minus x square, that will give us 3x square is equal to B M square. So we can rearrange. We can say that B M BM square is equal to, we have BM square is equal to 3 x square. So we can take the square root of both sides. Let me use this space. Can say that BM will now be equal to square root of 3x square, because square will cancel square if I take the square root. So this one is like saying square root of 3 times square root of x square. So this cancel this. All right, so we now have x left and root 3. So this one will give us x root 3. So BM in this case is x root 3. So we have gotten all the three sides of this triangle. So the next thing is for us to now get their special angles. So now each of them, they will have their own unique characteristics. So if I'm starting with 30, if 30 is my reference angle, then it implies that the side facing 30 will be the opposite. The hypotenuse is a constant side because that's the side facing the what? Right angle. While the adjacent is also very varying. So we can say that was sine what? Sine 30 degrees. So for the purpose of what I want to do now, I will use, because I'm proving for sine 30, I will use red pen to identify its opposite. So for sine 30, this side is the what? Opposite. That's for 30. So I will use red. I will style it so as to know that red is what represent those angles. So this is opposite. Then of course hypotenuse is fixed. Then this is what? Adjacent for 30. So in that case, we have that sine 30 is the same thing as what? So, which is what? Opposite. What is the opposite? That is what? X over what? Let me scroll up a bit. X over what? Hypotenuse. That is what? 2x. So this cancel this. This will give us what? 1 over 2. So sine 30 is 1 over 2. Then the next one is what? Cos what? Cos what? 30 degree. And that is what? Car. What is car? That is adjacent over hypotenuse. So what is adjacent? X root 3 over 2x. So we have what? That will be what? X root what? 3 over what? 2x. So x cancel x. We have what? Root 3 over 2. Then the next one is what? Tan what? 30 degree. What is tan 30 degree? That is what? TOA. So TOA in this case is opposite over adjacent. What is opposite? Opposite in this case is x. Then adjacent is x root 3. So that will be what? X over what? X root what? 3. So this one will be, this one cancel this out. We have 1 over root what? 3. But we need to rationalize this to eliminate this irrational number, which is root 3. So we multiply by root 3 divided by root 3. So this will give us what? Root 3 divided by root 3 times root 3. That is 3. How? Root 3 times root 3 will give us root 9. And square root of 9 will give us what? 3. So these are the 3 values we got for sine 30. So the next one will now be what? 60 degree. So for 60 degree, permit me, I'm going to remove this red now, because it will make so that it won't confuse us. I'll remove red here, right? Because for 60 now, the opposite would have changed. For 60 degree, this is our new opposite. So let me use green pen. So for 60, this is our opposite, right? Then this is now the adjacent, and hypotenuse is fixed, all right? Because that's the only side facing the right triangle. So now let's scroll up. So when we say 60, so don't forget I'm using green pen to represent those sides. So we now move on. For 60, we have what? Sine what? Sine what? 60 degree is the same thing as what? So, which is now opposite over hypotenuse. So what is the opposite of 60? That is what? X root 3 over what? Over 2x, right? So that will be what? That will be x root what? 3 over what? 2x. X cancel x. That will give us what? Root what? 3 over 2. So what do you notice? Sine 60 is the same thing as cos 30. But that is not what we are doing. So let's move on. Then we also have what? Cos what? Cos 60 degree, which is got to what? Car. So that will be what? Adjacent. So what is that is car, that's adjacent over hypotenuse. Adjacent is x over what? 2x. So that will give us what? This will give us what? X over what? 2x. This cancel this. That will give us what? 1 over 2. Then the next one is what? Tan what? 60 degree, which is got to what? TOA. What is TOA? That is opposite over adjacent. So what is opposite in this case? The opposite is x root 3 over what? Adjacent, x. So this gives us what? X root 3 over what? X cancel x. Then we have what? Root 3. All right. So looking at this, we can summarize that what? Sine what? 60 is got to what? Cos what? 30. which is equal to what? It's equal to root 3 over 2. It's equal to what? Root what? 3 over 2. Then also we have sine 30 is equal to what? Cos what? 60, which is equal to what? 1 over 2. So for those that would like to use the table of trigonometric identities, this is a very good one. So you can check this in your table of trigonometric identities, and if you master all this effectively, so wherever sine 60, sine 30, and you can just pick those numbers and use it to solve any of the problems that is given. I want to believe this video has helped someone. Please don't forget to subscribe to this channel, like this video, share, and please make comments. I'll be looking forward to receiving from you. Thank you, and see you in the next video. Bye.